Good evening to everyone. Welcome to GTQ session, Gate through questions of the DBMS. So, hope you are all doing good. Good evening to all. Is audio, video, everything is fine? Good evening, Balla, Umesh, Arbind, Kajal, Kundan, Rohit. Good evening to all. Good evening, Deepshika. So, session is around 2 to 3 hours, 2.5 hours or 2 hours 45 minutes approximately. So, based on the way you respond, and I am planning approximately 18, 19 or approximately 20 questions. Tried maximum possible areas, okay, just to recollect. Okay. So, are you ready? Good evening Vishwa, good evening Priya, good evening Aniket. Hope you are all doing good. Good evening Bonja, good evening to all. So, start with one simple question. Okay, it's first question. Question related to ER diagram as well as finding number of super keys. So, the question is how many super keys in minimized relational table of the given ER diagram. Okay, if this given ER diagram, if we convert to minimum RDBMS table, in that minimum relational database tables, okay, total how many super keys are there. Okay. So, first question is on the screen, and please take, I think it is required max to max 15 seconds. Good evening to all, good evening to all. Please post the answers. Right, okay. See, this is one-to-one mapping, total participation both sides. So, in ER diagram we studied if it is one-to-one mapping, total participation both sides, okay, the entities E1, E2 and relationship can be stored in the single relation. And before that, if you take the FDs, if you take the functional dependencies, A is key attribute, B is non-key attribute. So, A determines the B FD for the entity set E1, and C determines the D is FD for entity set E2, right? Okay. So, for relationship set, because of mapping is one to one, so the attributes of the relationship set is ACE. ACE is the attributes. Because of one to one mapping, A and C both are keys. Okay, A and C both are keys. So, FDs of this relationship set, A determines the CE is one FD, as well as C determines the AE is the other FD. These are the functional dependencies, right? So, if we convert this ER diagram to RDBMS table, one single relational table required. So, one relational table required for this ER diagram. So, E1 relationship set, entity set E2, okay, combinedly can be stored in the single RDBMS table. Then total 5 attributes, that is A, B, C, D, E. Total 5 attributes, right? Okay, and these are the dependencies, these are the FDs. So, because of E1, A determines the B, and because of relationship, A determines the CE also, and because of E2, C determines the D, and because of one-to-one relationship set, C determines AE also. So, to find number of super keys of the relation, So we need to find the number of candidate keys. So candidate keys of the relation is A and C. Candidate keys are A and C, right? A is one candidate key as well as C is one candidate key. So total 5 attributes in the relation. A is one key and C is one key. Then we need to find number of super keys. Okay, so number of super keys. So super keys among the prime attributes. Super keys among the prime attributes is 3 super keys multiplied with 2 power number of non-prime attributes. So 3 non-prime attributes. 8 3s are. So 24 total number of super keys. So answer to the question is 24. Right? Is this cleared? Very good. Okay. So majority given 24, some are given only 8. Okay. So the given ER diagram is there, and based on the mapping and based on the attribute set, okay, so we need to see the functional dependencies. Once you convert into RDBMS table, one single RDBMS table is required. In this, for this relation, 2 candidate keys, okay, so 2 candidate keys and 5 attributes, and 3 are the number of super keys among the prime attributes. 2 to the multiplied with 2 power number of non-prime attributes. Otherwise you can do like this also, which we done in the class, number of super keys of first candidate key, number of super keys of second candidate key. So because of the first candidate key, number of super keys are 2 power 4, and because of second candidate key, number of super keys are 2 power 4. The intersection part, number of super keys among AC is 2 cube. Okay, total number of the super keys. Okay, so super keys of candidate key A as well as super keys of candidate key C and intersection. Okay, so 2 power 4 plus 2 power 4 minus 2 cube is the total number of super keys, 24 super keys, right? So hope it is clear this. Okay, so let's move to the next question. Is also related to the ER diagram. So E1, E2, it's a many to many mapping is given, and A single valued attribute and key attribute, B is also single valued attribute, C multi-valued attribute, D and E single valued attribute with D is a key attribute, F multi-valued attribute, and it's a many to many mapping. So how many minimum relational tables required which satisfy BCNF? How many minimum relational tables required which satisfy BCNF? Right. Very good. Nitin Kumar, Hari Krishna, Akshay, Ishika, Keshav, Bhuvanesh, Rohit. Sanket, Divyansh. Yeah, everyone given correctly. So see, so the many to many mapping, it's a many to many mapping, so we need 3 relational tables. In general we need 3 relational tables. Okay, so E1 is one relational one RDBMS table with ABC are the attributes. Okay, so because of C multi-valued attribute, so A key attribute determines the B but not C. Okay, actually because of this multi-valued attribute converts to single valued attribute, it forms multi-value dependency. A multi-value determines the C. A multi-value determines the C is the multi-value dependency, right? But this multi-value dependency is not required for BCNF, right? So we can ignore this multi-value dependency for the BCNF or 2NF or 3NF or okay 1NF. Okay, if you want to design fourth normal form, you need to think about the multi-value dependencies. Okay, so relationship set. Okay, so A and D combinedly key, no non-trivial FDs because many to many mapping AD combinedly key. So entity set E2, so DEF, DE as well as F. Okay, so D determines the E is FD, E is a single valued attribute depending on D, and also D multivalue determines F. Okay, also D multivalue determines F, but we ignore this MVD. Okay, so now in this case AC is become key. Okay, and in this E2 DF is become key. Okay, so because of partial dependency we have to split this E1 because it's not BC enough. Okay, we have to split this E1. So the one subrelation attributes AB, one subrelation attributes AB with A is the key, and one other subrelation attributes AC. AC combinedly key here. Okay, and relationship set key AD is the attributes for relationship set. AD combinedly key here because of many to many mapping, and E2 also has to be decomposed. It's a partial dependency, not BC enough. Okay, so DE, okay, DE and D determines the E, and D is a candidate key. So here D determines the E, and here A determines the B. Here non-trivial FDs are not there, non-trivial FDs are not there, and one other relation required, that is DF. Okay, no non-trivial FDs. Okay, so because of relationship set, okay, because of the relationship set, this A is foreign key. A is foreign key refers to A, and also because of this extra decomposition, this is one foreign key, and D foreign key refers to here, and because of E2 subdivided, and D foreign key refers to here. Of course, anyhow the number of foreign keys is not the question, total number of relations. So total number of relations are 5 relations are required. Now this decomposition is satisfied, BC enough. Okay, BC enough as well as lossless join is also satisfied, dependency preserving is also satisfied. Okay, so the total 5 relational tables required. If in case C and F are single valued attributes, in case C and F are single valued attributes, then 3 relational table only. Okay, because of this multi-valued attributes and BC enough, so we need to further subdivide, okay, E1 entities into 2 tables, and E2 entities into 2 tables. Relationship is separate table. Okay, total it required 5 relational tables, right? Clear this one? So post your comments, and if you have any doubt on this. Right. Shall we move to the next question? Even if BCNF, who is that? Vishwa. Even if BCNF is not given, still it is 5 tables only. Even if this BCNF is not given, still it is 5 tables only. The reason is okay, it is satisfied 1NF, no problem for the 1NF, as 1NF is okay, but the problem is this A should be foreign key refers to here. This A should be foreign key refers to here. D should be foreign key refers to here. To reference this foreign key, okay, the A must be a candidate key, but in this table AEC is the candidate key. Okay, because of foreign key reference is required. Okay, so the even if it is not given BCNF, still answer must be 5 only, right? So if foreign key reference in case okay, so A is already a candidate key or D is already a candidate key, then you need not require to further decompose. Okay, so but because of this foreign key reference is not possible, right? So foreign key should refers to a candidate key, but for this relation A is not a candidate key, AC is a key, and this foreign key should refers to D is not a candidate key. For this relation DF is a key, even if not BC enough, and still it is 5 is the correct answer for so converting the CR diagram to RDBMS table. Okay, so without foreign key referencing, and there is no meaning of relationship set, right? right. Okay. Yeah, it is related to views, virtual table. Okay, it is one conceptual question. Okay, multiple selection question, MSQ. Multiple selection question, and just view is a virtual table. Just think and answer what is correct option. Okay, regarding views of the database table. So Akshay asking previous one, so just check it once. We have to make multi-valued attributes for another table. It depends on the normal form. Okay, sometimes even if multi-valued attribute doesn't separated in other table, still it may satisfy for one enough. Okay, so it depends on the question. Don't make a blind statements. Right. Right. So view is a virtual table. Okay, so you all know, so we define, like we say, assume that there is a database table. So employee database, employee ID, employee name. Okay, so department number, salary, address, etc. So there may be many attributes are there. So we can create view for this schema. Okay, so it's a virtual table, data not stored in the view is a virtual table. Okay, so we create like this, create view. Okay, view name, let's say employee 1, and we write the data which required for the view. Let's say what are attributes required for the view. So employee ID, employee name, okay, salary and department number. These are the attributes required from the real table, from the employee relation. So you can apply some where condition also. View is allowed to, okay, take required attributes, as well as view is allowed to take required records also. Okay, record selection also allowed for the view. Let's say only department 5 employees are the one view. Like this we create the view. Now we can use this schema employee 1 as like the RDBMS table, okay, as like the RDBMS table we can use this view, okay. So but data is not stored in this view, data is whenever we write the any query, so for example if you write some query related to this view, okay, let's say, okay, select average salary, okay, select average salary from employee 1, okay. See, like this we can write SQL query to this view, okay. Now first it will using this physical table, means RDBMS table, it will compute this data, it computes this data by using data records of this view, okay, and it will compute this query. So views is not improves the query execution, okay, it's not improves the query execution. For example, if you apply this query directly to here, so directly executed one query, but what happened now? So using the original data, this view is computed, using this view and this required calculation is computed, means it is like a one extra query to get the required data. So it is not improves the efficiency of the query. They helps to provide data independency, okay. So we can provide data independency by using the view. Different users can view different way for the same database table. That is the fundamental idea of the view, okay. Different people, one person can view only one two columns, other person can view other portion of data, other person can view one certain subset of the records, okay. So different people can view differently for the same data, okay. So that is the fundamental benefit of the views, okay. It is used for user interface, right. So they allow schema changes without forcing existing application. It's a false statement. So many are given C is a correct statement, C is a false statement, because if I change the schema, okay, so I have to recompile the view, I have to recompile the whole application, okay. So because the actual view is depending on the schema only, view is the depending on original schema. If schema is changes and view has to be changed and recompile the application, okay. This query need not be works if schema is changes. If schema is changes, view not works, and view not works means the application has to be recompiled, right. So now, so C is false statement. They helps with access control. This is also another advantage, okay. So like different based on the role of the user, okay. Assume that one set of users, okay, one category of the users, okay, not allowed to see the address, other category of the users not allowed to view the not allowed to see the salary. Like subset of conceptual schema can allow for different sub users, okay. So this is also correct statement. These are the real advantages of the views, okay. It is help for data independency, okay, and it is helps for access control, okay, security. So this is about the view, right. Thank you Raman, thank you Kasif. Please be patient, and one question may be difficult and one question may be easier, okay, and so solve with your best effort, put your maximum effort to answer the question, doesn't matter is it right or wrong. Clear this one? Next, let's move to the next question. Now it is normalization question. It is one of the standard model question, you all know, okay. From normalization, so lossless join decomposition and dependency preserving decomposition are important things, okay. So the 4 FD sets are given for the relation ABCD, 4 FD sets are given and decomposed also, decomposite subrelations are given. So out of these 4 FD sets, how many decompositions are lossless join decomposition and dependency preserving? Lossless join and dependency preserving means for all the 4 decomposition you have to find lossless join and dependency preserving. Okay, so these days after introducing multiple selection question, the paper becoming little lengthier also. Okay, so don't think like this is lengthy question and all, because it's a simple 2 to subrelation na? So not difficult for finding lossless join and not difficult for finding dependency preservation, but still some of the questions can be expected to be little lengthier. Okay, okay, so take 2 minutes time and finish it. Ishika Jain. So I am expecting once you study DBMS from me, okay, you should not have my means you should not require my help for the DBMS forever. Okay, so it's not like always should be a student to a one particular faculty na. Anshuna, please check again. Priyanshu, check again. Akshay, check again. Iswar. Very good. Is it required little more time or shall I continue? Right. So lossless join is much easier. So the only two subrelations are there. Every attribute should be in the subrelation. So all attributes of subrelations, okay, should cover the attributes of relation R. No attribute should be missed. Okay. So and second thing, common attribute between the subrelations should determine every attribute of either first relation or every attribute of the second relation is the lossless join property. Okay, this is the lossless join rule, right? Right. Okay, so common at see here A, B, C, D, every attribute is there. So if you take common attribute B, so if you take the B closure, okay, B closure, so B closure determines C, okay, so which is key for one of the subrelation. B closure determines the C which is key for one of the subrelation. So because B closure is BC. Okay, so this first one is lossless join. First one is lossless join, right? And is it dependency preserving or not? Okay, so dependency preserving or not. So for first subrelation, okay, AB is one subrelation and second subrelation is BC. Okay, so if you take the FDs of subrelation, A closure not determining the B, B closure not determining A, so no non-trivial FDs for first subrelation, and here B closure determines the C, B closure determines the C, B determines the C is the FD, C closure is not determining the B. So and only B determines C is preserves and D determines A is lost. Okay, so it is lossless join. Okay, it is lossless join is true, but dependency preservation is false. Lossless join is true, dependency preservation is false. Now second FD, second relation. Okay, ACD and BC no attribute is missed and common attribute is which is common attribute here, C is a common attribute, and C closure determines CAD, C closure determines CAD. Okay, so C closure determines CAD means C is key for this relation, C is key for this relation. It is also lossless join decomposition. Okay, this is lossless join decomposition, but see the dependency preservation. So R1 is one subrelation with the attributes ACD. Okay, R1 is one subrelation with the attributes ACD and R2 is other subrelation with the attributes BC. So find the FDs of subrelations. Okay, A closure not determines CD and C closure determines AD. Okay, C determines the AD is one FD. Okay, and D closure is also only D, right? D closure is also only D. Then so AC closure, AD closure determines other attributes and it is redundant FD. Then CD closure is also only CD. C determines AD is the FD for the first relation. B not determines the C, C not determines the B. Okay, so C determines AD is preserved and AB determines C is not preserved. AB determines C is not preserved. Second one is lossless join, but second one is again failed for the dependency preservation. Okay, then third question. So common attribute between the relation is A. A determines the BC. A determines the BC. A is key for one of the subrelation, first subrelation. It is again lossless join decomposition. Lossless join decomposition. Let's see the dependency preservation. So ABC is one subrelation and second subrelation is AD, right? So ABC and AD are the two subrelations. So A determines the BC is 1 FD. A determines the BC is 1 FD. C determines A and it means A determines the B. It means C determines AB also. Okay, C determines AB also. Okay, because C determines the A means A determines the BC. So C determines the AB is also FD here. And the second subrelation, A determines the D. A determines the C and C determines the D means A determines the D also. Okay, so if you take the D closure, D closure is not determines the A. So these are the FDs. So if you observe, A determines BC is preserved and C determines A is D also preserved. C determines A is also preserved. It is lossless join as well as dependency preserving. Dependency preserving is true as well as lossless join is true. And this one both dependency preserving and lossless join. Then last one. So AB the lossless join decomposition. So common attribute between these two is B, which is key for second relation, and ABC can be joined, and common attribute between second and third C, and C is key for this third relation. So it is overall lossless join decomposition. So it is also satisfied lossless join decomposition. So if you take dependency preservation, one subrelation AB and second subrelation BC and third subrelation CD. Okay, so A determines B and B not determines the A, and B determines the C as well as C determines the B is the two FDs for second relation. C determines the D is one FD for third relation, D not determining the C. These are the FDs of the subrelations. So all FDs are preserved. A determines B preserved in first relation. Okay, B determines C preserved, C determines B, and C determines D also preserved. It is also dependency preserving. Okay, so the third one is lossless join and dependency preserving. Fourth one also lossless join, dependency preserving. So these two are lossless and dependency preserving decompositions. So the answer to this question, so two decompositions. It's a numerical question. So answer 2. Right? First one is sorry for this. First one is not lossless join. First one is not lossless join. So by overlook I didn't observe this. Okay. So here attribute D is not in the subrelations. Attribute D in the not subrelations. So this first condition is failed. Okay. Attribute D is not in subrelations. Attribute D not in subrelations. So first one is not lossless join as well as not dependency preserving. Second one, third one, fourth one lossless join, but second one not dependency preserving. Okay, third and fourth lossless join as well as dependency preserving, right? So by overlook I thought that D is in the subrelation. So D is not in any of the subrelation. Even though common attribute B is key for one of the subrelation, attribute D is missed because of decomposition. It is a lossy joint decomposition, right? Right? Shall we move to the next question? It is again normal form question. Okay, so it is not about just answer and try to recollect the means key points required for this topic. Okay, so first two claims are given. Okay, two statements are given. If relational schema R is in 3NF and at most one compound candidate key in relation R, then relation also in BCNF. Okay, if relational schema R is in 3NF but not BCNF, then a relation must have overlapped candidate key. So what are true statements? Okay. Right. some are given B and some are given C. So see this one, relational schema R is in 3NF, relational schema R is in 3NF, at most one compound candidate key, at most one compound candidate key. See, if you think about, whenever we say a relation R is in 3NF, but not BCNF. For example, if you take relation R is in 3NF but not BCNF, okay, so it is possible only if, okay, of course it's already in 3NF, means no partial dependencies, already in 3NF, no partial dependencies, already, okay, 3NF means no non-prime determines other non-prime kind of dependencies, okay, because already he says that it's a 3NF, okay. But if it is not BCNF, only one possibility, so that is proper subset of candidate key, okay, proper subset of candidate key determines proper subset of other candidate key, okay, proper subset of other candidate key, okay. So this kind of FD should be exists, okay, this kind of FD should be exists, then only 3NF relation can fail the BCNF, okay. This is only the possible case where BCNF is failed if it is 3NF relation, okay. See here two things is given, 3NF is already given, okay. So it's not like not BCNF means only this is the case, okay, not BCNF means even if partial dependency exists, not BCNF, even non-prime determines other non-prime exist, also not BCNF, okay. So why we are only saying this is the possible case, because already 3NF is true, only BCNF is failed, this kind of FD is exist, okay. So to have this kind of FD, for example, let me take one simple example, ABC, okay. So AB determines the C is one FD and C determines the A is other FD. So the candidate keys of the relation is ABC, AB is one candidate key, so BC is also one candidate key, other two candidate keys, right. So see, if you observe, this relation is 3NF, AB is super key and C is not a super key but A is a prime attribute, okay. This relation R in 3NF, okay, but it is not BCNF, it is 3NF but not BCNF. So whenever we say 3NF but not BCNF, you can definitely find, see, there must be at least one, okay, FD which is proper subset of key determines the proper subset of other key, okay. So to form this kind of FD, so at least two compound keys are mandatory, okay, at least two compound keys. Otherwise this kind of FD is not going to be formed. If this kind of FD not forms, BCNF is not fails. 3NF relation guaranteed BCNF if this kind of FD is not there. The 3NF is true, BCNF is false, mean this FD is exist, means at least two compound key, because proper subset of key should determine proper subset of other key. So he says that at most one compound key, So if at most one compound key, there is no chance of proper subset of candidate key determines proper subset of other candidate key. This kind of FD is not possible, okay, this kind of, because of this, okay, proper subset of candidate key determines proper subset of other candidate key is not possible with 3NF relation. 3NF relation and this kind of FD is not possible, such a relation guaranteed in the BCNF. Okay, so the first statement is true, okay. Then if relation is 3NF but not BCNF, Okay, in this case direction statement 3NF but not BCNF, they must have overlapped, and this kind of FD means overlapped candidate key. AB is one candidate key and BC is other candidate key, 3NF but not BCNF, B is common. Such a candidate keys are called overlapped candidate keys. Okay, overlapped candidate keys, and both are compound candidate keys. So these are the three statements guaranteed true if 3NF but not BCNF is the given relation. So overlapped candidate keys exist. Okay, so if 3NF relation but not BCNF relation, okay, if the given relation is 3NF but not BCNF, guaranteed these three statements are true. Okay, that doesn't mean that overlapped candidate key not BCNF. Okay, that doesn't mean that two compound keys are not BCNF. Now reverse of the statement is not true. Okay, so it's not like it's only if then statement. If relation 3NF but not BCNF, then these 1 to 3 are true. Okay, so but if by chance if they say two overlapped candidate keys, two compound candidate keys, two overlapped candidate keys, then relation is not BCNF, may not be. So reverse of the statement need not be true. Okay, so such a conceptual questions is also possible. So second statement is also true, both the statements are true, right. So Sambhav says that AB determines C and B determines D. Okay, so if you take AB determines C and B determines D, it is not only fail for BCNF, also fail for 3NF, because that B determines D is partial dependency. Okay, so the question is not about the not BCNF only one condition. The statement is not like only not BCNF. The statement having two parts. One is already in 3NF but not BCNF. Okay, so the whatever FD set you are given in the comment, it is not 3NF and not BCNF. Okay, not 3NF and not BCNF is not the meaning of the statement. Okay, hope it is cleared, right. 50% given C and 50% given B. So those who are given option B is correct answer. So are you cleared this, right? Shall we go to the next question? Comment, make it fast. Right, next question. It is a relational algebra question. Okay, a relational algebra question. Employee ID, salary, department number and gender. Okay, so like this relational algebra query is given and you need to find correct option. It is also multiple selection. Okay, it is also multiple selection question. So think and answer. right. So 1 2 3 4 5, okay, 6. So for 7 comments are correct and remaining are wrong, right. Okay. See this question. This is the given relational algebra query. This is the relational algebra query is given. Okay, let's analyze this query. See, so join is something like sum any at least one. Okay, join is behaves like sum any at least one. Okay, so employee join with other employee instance. Okay, so employee and from first instance selected females, female employees, from the second instance selected male employees. It means so female employees compared with the male employees, female employees compared with the male employees, and there are two other conditions. One is the salary of the first instance, salary should be less than equal to sum of the record in second instance, and department is same, department number is same. So and we are retrieving EID of the first table, means females we are retrieving. So this subquery retrieves employee IDs of the females. Okay, employee IDs of the females, female employees, okay, just direct conditional join means whose salary less than equal to, because of conditional join, sum, okay, some salary of male employees, some salary of male employees for their own department, same department means of her department. Okay, because of this condition of her department. For example, if department 2 is there and department 2 female salaries are compared with department 2 male salaries, okay, of their own department. Okay, so her department means indirectly for the same department. Okay, so these are the female employees whose salary less than equal to some salary of male employees of her department, means their own department. Okay, means these female employees are subtracted from all EIDs of the females. Okay, all female employees. Okay, all female employees minus EIDs of all female employees minus, okay, so female employees whose salary less than equal to, okay, some salary of the male employee, okay, for their own department. The result is become complement of this one. This is a bigger set and it's a smaller set, all females, and here some of the females we are retrieving from bigger set. If you subtract the smaller set, the result is complement for this set. Okay, answer is complement for this set. What are complement females for this one? Okay, so complement female IDs are, okay, employee IDs of the females, okay, of the female employees, okay, whose salary not less than equal to sum, not less than equal to sum, okay, not less than equal to sum means greater than every complement, greater than every salary of her department. Is the result. Okay, EIDs whose salary, EIDs of the females whose salary greater than every salary of their own department. Okay, so is the output of this question. Let's see what is the correct option, correct answer. Salary, okay, retrieves EIDs of all females, retrieve EIDs of all females whose salary more than every male employee salary of one department. It's not like, okay, every male employee salary of the one of the department, okay. So it is every salary greater than every male salary of their own department for the same department, okay. So the first one is, it's not like we are comparing with one particular department, okay. So the salary more than every male employee salary of her department, okay, this is what the correct answer, okay. Salary less than equal to, not less than equal to every, not less than equal to every, not, sorry, not less than equal to some, okay. So this is greater than every, it means that not less than equal to some, okay. So he is saying that less than equal to every is false, okay. So now the C is the false statement. So salary, female employee IDs whose salary not less than equal to some male employee salary of her department, okay. So either we say not less than equal to some salary of their own department or greater than every salary of their own department. According to the set theory, these two statements are equal statements. So B and D are equal statements, okay, both are means the same, okay. So the answer to this question is BD. Right? Is this clear? It is one standard model question, okay. So in GATE examination, either from the SQL or from the relational algebra, same model question, same kind of set difference model question, okay. So you can find at least 12 to 15 times in the previous GATE. The same logic, exact same logic, table name changes and attribute name changes, okay, either it in SQL or it is in relational algebra, right. Akshay, Yogita, Rohit, Ishika Jain, cleared. Shall we move to the next question? Nidhi cleared, okay. Move to the next question. It is also relational algebra, it is a much simpler question. I think everyone should give the correct answer. So relational schema, relational algebra again, okay. So catalog table, supplier ID and pot ID combinedly key, supplier ID, pot ID combinedly key, and pots table PID is the key, and the simple set difference query is there, okay. So what is the result of the given relational algebra query, okay. Don't hurry, and so just think properly and give the answer, okay. So you should give correct answer for this question. It's a one standard model or simple question only, right. right. Okay. So majority given correct answer. Okay, even those who are given a wrong answer and one option is correct and other option is wrong. Okay, so this is the given query. Okay, see, we are retrieving SIDs, means see, catalog SIDs, okay, so which consist SID port ID combinedly key. Because of SID port ID combinedly key, this catalog SIDs are supplier ID who supplied at least one port. Okay, supplier who not supplied any port, doesn't means not entered into the catalog table, because SID port ID combinedly key. Okay, supplier in the catalog table has supplied at least one port. Okay, so these SIDs logically we can say, so supplier IDs who supplied at least one port, these are supplier IDs, SIDs of the suppliers who supplied at least one port. Okay, now catalog table join with the red ports. Okay, catalog table join with the red ports. So natural join is generally for sum. Okay, so it will give, the second query gives the supplier ID who has supplied at least one of the red port equal to some red port. Okay, it will give SIDs who supplied at least one red port. This is SIDs who supplied some, means at least one red port. Okay, see, supplier who supplied some port minus, from that set we are removing supplier who supplied at least one red port. Okay, the remaining suppliers are supplier who supplied non-red ports. Okay, supplier who supplied non-red ports. Okay, it need not be all non-red ports. For example, okay, so 5 red ports are there and 5 non-red ports are there. Okay, we are expecting he has supplied one of the port, but it is not a red port. He has supplied at least one of the port, but not a red port. Okay, but not any red port. So it means that supplier who supplied only non-red ports. Okay, so it need not be every non-red port also. Okay, one or more non-red ports, but not any red ports. Okay, so but third option, many are saying that third option, supplier who supplied every non-red port. Okay, so this required division. Okay, we can't directly do this kind of join with simple set difference. Okay, it required division. Okay, so this is not a correct answer. Supplied some non-red port. Okay, of course he supplied some non-red port. It's not only supplied some non-red port. Okay, so he is not supplied the red port. Okay, so it's not their complete statement. Okay, so first one is false and third one is also false. SID supplied only green port. Okay, so it supplied some non-red port, it need not be only green port. Okay, so it may be some other color also. Okay, blue port, or it may be supplied only one blue port or only 2 blue ports, that is also in the result. Okay, so in this way the D is also not correct answer. Okay, so answer to this given question is B. So even it is given as MSQ, but one correct answer, right? So many are given BC, many are given BC. Post your comment why C is wrong. Post your comment why C is wrong. Yes, okay. Yeah, C is like a division, okay. It's not required to be, the query not going to be retrieve SID who supplied every non-read part, okay, even if it is not supplied all the non-read parts, okay. If he supplied one of the non-read as well as not supplied any read, okay, still he will be in the result, right, okay. So hope it is clear. Simple set difference query. Generally set difference means only, okay, so say only but not, these kind of things we use set difference. Union, either this or this, intersection, common set, okay, and okay, similarly set difference but not, okay, only, okay, these are the some key, so the some of the key terms you can understand, okay, we can focus, so so that you will able to eliminate easily, okay. Is it okay font size? It is also a relational algebra query, So consider given relational schema, xy, which is used to store graph edges, okay. So each directed edge xy of the graph, okay, is record in relation R. One graph edge is the one record, okay. Which of the given relational algebra query cannot be expressed in constant length, okay. So which is failed to express by using relational algebra indirectly, okay. Retrieve vertices which have self loop, okay, retrieve vertices which have loop at most 2 vertices, and retrieve vertices which have forms the loop, and retrieve vertices which are, okay, are reachable from the given vertex. It's MSQ question, okay. So so it is one important model. Indirectly what kind of queries fail to express in the relational algebra, okay. So is the one important logic repeatedly used to ask many competitive exams, okay. So think and answer. Right. So all are given BC. Please check answer once again. Okay. So everyone given BC. Everyone is given BC. Okay. Please recheck. right? Who are given correct answer? So very less people given correct answer for this question. So Onika Yadav given correct answer. Rohit, Monishka, Pratik, Vishwa, Nath, right. So I hope you cleared the question. It means that graph edges are stored in the RDBMS table. For example, if we have some graph like this, okay, so the graph edges are stored in RDBMS table. So assume that there may be a self loop, because one of the option he is mentioned self loop, okay. So there may be some self loop edges, are so edges of 2 vertex loop, are edges of 3 vertex loop, are edges of loop for all the vertices, okay. So any such graph we are stored in one RDBMS table. So the table name is given relation R. So these graph edges are stored in this table, okay. X is X and Y. So A to A edge, A to B edge, and B to A edge, and B to C edge. So example graph, okay, sample data, okay. So D to D edge, and D to C edge, and C to A edge, right. This kind of database table is given, okay, which represented as graph edges. Now which of the following cannot be expressible in constant length relational algebra query, okay, cannot be expressible in constant length relational algebra query is the question. So some are given first option also. So retrieve vertices which form self loop, okay. Self loop means A equal to B, sorry, X equal to Y, X and Y is equal, then self loop. It is easy to write the relational algebra query, na. So constant length query we can write this, okay. So simply from this relation R, so retrieve the record whose attribute value X and Y is equal, and project the X, okay. Write that, it will give self loops, okay. So A equal to A and D equal to D, okay. A and D forms the self loop, okay. It is a constant length query, and so it will work for retrieving all the vertices which have self loop, and retrieve vertices loop at most 2 vertices, okay. Loop with at most 2 vertices, it may be self loop or it may be a loop of 2 vertices, okay. So if length is given, loop length is given, then also we can able to express, okay. So for this second question we need 2 instances of the table, okay. 2 instances of this RDBMS table. See what so 2 vertex loop means there should be edge from A to B and there should be edge from B to A, right. So it means that there is one record AB should be exist, other record BA should be exist. It means this is the X value and this is the Y value, okay. So first record Y value, second record X value should be same, and first record X value and second record Y value should be same. So that means if you do cross product between these two tables, and this X is equal to Y and this Y is equal to X, okay. So if you then this is also, okay, true. The self loop is also at most 2 means it includes self loop, okay. So this AB BA, okay, BA AB, okay, but this D and D, this is true. This remaining BC is fails because CB is not there, DC is fails because CD is not there, CA is fails because AC is not there, right. So now these are the records which satisfied, so A and D, okay, A and D which forms vertex, okay, B, this also ABD is forms vertex which at most 2 vertex. So first relation X should be equal to second relation Y, that means renames to Y1, and the first relation y should be equal to second relation x, which is renamed to x1. These are the two conditions over the cross product. Okay, so in this we apply the one of the attribute. Okay, this will give the loop with at most second option query. It is also constant length query. Both are constant length query. See, the length is given, it is okay, but the third one forms the loop or not. Okay, forms the loop or not means, so it may be self loop, or it may be 2 vertex loop, or it may be 3 vertex loop, or it may be 4 vertex loop, or it may be n vertex loop. Okay, so the length is okay not given. So if 2 vertex loop, if you want 2 table cross product, 3 vertex loop if you want 3 table cross product, so how it will be going to the 3 vertex loop. So 3 vertex loop means AB and BC and CA, like this should be exist. 3 records should be compared, means 3 table cross product required, and 4 vertex loop is exist if you want to retrieve vertices which forms the 4 vertex loop, and we need to cross product 4 tables. Okay, so then this query not constant length query. Okay, so this C is the not constant length query. So you have to do like this one, R1 cross product R2, assume that R1 R2 R3 up to so on Rn is the renaming of relation R, same relation R. Okay, so n, what is that n, we don't know, the length is not given, so we need to write the lot of conditions. This is not constant length query. What are those conditions? So first relation y should be equal to second relation x, and second relation y should be equal to third relation x. Okay, so end operation and up to so on. Okay, so n minus 1th relation x is nth relation y, and okay, nth relation x, okay, this nth relation x y, so n minus 1 y n minus 1 relation y is nth relation x, and okay, nth relation y is first relation x. Okay, like this you can write the query, but this length is not constant because we don't know how many vertices are forms the loop. It is not constant length query. So it is indirectly says that fail to express by using relational algebra. Okay, fail to express using relational algebra because length is required. Okay, so it is about the C question. And D, retrieve all the vertices which are reachable. Okay, the reachability is also have a problem by using the relational algebra because we don't know what is that length of reachability. Okay, it may be direct adjacent of the given vertex. Okay, it may be direct adjacencies, or it may be two vertex length. The reachability can have okay a 2 vertex length. Okay, or so reachability can have 3 edge length from the source. Okay, let's say this is E and this is F. Okay, like this. Okay, this length of reachability is required. Okay, so length of reachability required. So this is the reason it is also not constant, similar to the third option. It is also not constant length query. Okay, so the C and D. So whenever the query need length, okay, whenever the query need length of the length to express, okay, so which is failed to express by using relational algebra and failed to express by using a relational calculus, either tuple relational calculus or domain relational calculus. Okay. So if for example if the reachability of at most 2 edges, reachability of at most 3 edges, reachability of at most 5 edges, okay, that length of reachability is given, can be possible to express. If length is not given, we don't know how many table has to be cross product. Okay. So clear this one, it is one important model question. Okay. So right. Thank you Kundan. Ajay understood. Explain D. Okay. So Singh. Okay. Yeah, see, so reachability we want. For example, if you want to write the query, I want all vertices reachable from vertex A. We need all vertices are reachable from vertex A. A is a given vertex. See, to get these adjacencies, okay, one edge length reachability. To get these adjacencies, one table is required, one instance of the table is required from the relation R. Okay, so x equal to the given vertex A, x equal to given vertex A, and project the y, so which will give the adjacencies. Okay, which will give the adjacencies, union. Okay, then next we need 2 edge length reachability, these vertices, 2 edge length reachability, these vertices. To get these vertices which are reachable from A, so we need 2 table, because one record is AB and other record is BC. So first record x equal to A, second record first record y, second record x, and second record y should be retrieved. Okay, so 2 edge length reachability if you want, I need to cross product 2 instances, and R1 one instance and R2 is one instance, and now I applied the condition like this. Okay, so for first record x equal to A, first record x equal to A, and first record y, okay, that means R1 dot x, R1 dot x equal to A, then R1 dot y should be equal to R2 dot x. So like first record is AB and second record is BC, assume that. So first record y equal to second record x, and we projected the second record y, okay, second relation y. So it will give 2 edge length from the source. Okay, so 2 edge length from the source. If I want to get the next 3 edge length from the source, okay, I need to cross product 3 tables, union. Okay, so we need to cross product 3 tables, R1 cross product R2 cross product R3, and like write the conditions like this, write the conditions. Okay, R1 dot x equal to A, R1 dot y, R2 dot x, R2 dot y, R3 dot x, R3 dot y is projected. Okay, so got it. So like this, based on the number of edges which is required for the reachability, so assume that if n edges involved for the reachability, then you have to cross product n table. Okay, you have to cross product the n table and write the proper conditions and project the last record y value. Okay, so length of this query is not constant, because we don't know the number of tables which is need to cross product. Okay, that depends on number of edges for the reachability. Okay, so because of that, if this instead of this, if they say all vertices which are reachable at most 2 edges, means 2 levels, at most 2 levels length is given, then the first and second, this part, this much only, then query length is constant, then it is possible to express, and it is also like a C option, not constant length query, right. Right, let's move to the next question. Thank you Akshay, Singh cleared. Ishika Ajay, thank you. Now it is also relational algebra question, make it fast. So I think almost 1.5 hours. Okay, so till around 10 more questions are there. Okay, so 3 tables are given. Relation R with A is a key, primary key with 100 tuples, C is a primary key with 50 tuples, AC combinedly a primary key with 75 tuples. How many maximum tuples in the result of natural join RST? Okay, so not only R and S. Okay, so as to include this one RST. How many maximum records in the result of RST? Right, do this. Majority are given 50. Right, okay, so 50-50%, okay, of given correct answer and of given wrong answer. Okay, so it's not required to remember, okay, but just I will give you the hint. Okay, so for example, if common attribute, okay, so let's say xy and the second relation is yz. Okay, common attribute key for one relation, first relation, but not key for the second relation. Okay, it is unique because the join based on this equality of the common attribute, right? Okay, so if it is unique for first relation, not unique for second relation, number of records, maximum number of records which satisfy the join, okay, assume n and m tuples are there. Okay, so it forms one to many mapping. Okay, one to many mapping because this y value can be repeat, something like this. Okay, so then the joint result, okay, the joint result maximum m tuples. Okay, if common attribute key for both the tables, okay, if common attribute is key for the both tables, just quickly revising, so that you will apply these questions easily. For example, common attribute is y, is y, which is not key for anyone. Okay, which is not, join is done based on the y, but which is not key. X is key for first relation, y is key for, z is key for second relation. So it is not key for any relation. Okay, so if it is not key for any relation, it forms many to many. Okay, something like it forms many to many. Then maximum records are n multiply with m. Maximum records are n multiply with m. Then the third possibility, so common attribute is not key for any relation. Okay, common attribute is key for both the relations. Okay, let us say based on y the joining is done, y is key, y is candidate key for both the relations. Because y is candidate key for both the relations, so mapping is one to one mapping, only one to one mapping is possible. So maximum tuples are so minimum of nm. Minimum of nm is the maximum tuples. Maximum tuples in the result, minimum of nm, right? So join is commutative and associative. Join is commutative and associative. It means you can do R join S, S join R, or S join T and T join R, S, or you can take R join T join S or S join T join R. Order doesn't matter, and so commutative also, you know meaning of the commutative, right? So you can take these three table any order. In case the first two relations are joins, assume that first two relations are joins. No common attribute means cross product, the result is cross product. Okay, the resulted attributes are ABCD. Okay, the resulted attributes are ABCD. It's simply a cross product. Okay, so that means the result is becomes so 100 records here, and the T relation which is C and D, 100 multiplied with, so this one, okay, 100 multiplied with 50, okay, it is becomes 5000, right? So 5000 tuples. For this 5000 tuples AC is unique. AC is key for the 5000 tuples. Okay, now that is get joined with the T. Okay, this result is get joined with the T. For T relation is also AC is the key. For T relation also AC is the key. So now here also AC is the key. Okay, now because of AC is key, and here the 75 records are there, and now common attribute key for both the table, the joint result is minimum of 5075. So overall the result is 75 tuples. Okay, even if you try other order, if you do S join T and then join with R, then also you will get the same answer, because join is commutative as well as associative, right? Yeah, everyone given 75 now. Now let's move to the next question. SQL question. So employee ID, employee name, supervisor ID can be null if employee not subordinate of other employees. Okay, so if he is not subordinate for anyone, for that record supervisor ID is the null. Okay, so which is correct query to retrieve employee ID and names of employees who are supervisors. Okay, employee IDs and names of and of course assume that e name is also there. It's not about the selection mistake. Okay, so logic of the query, think of it. Okay, so retrieves EID names of the employees who are who are not supervisors, okay, who are not supervisors, okay, not like who are supervisors, who are not supervisors. So is the given question. So supervisor ID can be null. We retrieve which is correct query. So retrieve employee ID names of the employees who are not supervisors. Okay, so think and answer. Right, okay, I think everyone given correct answer. So almost all are given B is correct answer. Okay, so just briefly I am explaining why first query is fails. So assume this is one employer relation, employee ID, employee name and supervisor ID. Okay, so employee ID is the primary key. So names of the employees, if he is not subordinate of anyone, it can be null. And let's say E1 is the supervisor for E2, E3 is the supervisor for E2 is the supervisor for E3. Like this, some simple database is given. Okay, now he is asking employee who is not supervisors. Okay, E1 and E2 is supervisors, E3 is not supervisor, he need name of the E3. Okay, so name of the E3, because E3 name is C is the E3 name. Now, so what is our requirement? We are retrieving employees, retrieving employees whose employee ID not equal to all, not equal to every supervisor. Okay, so logically it is correct, logically it is correct. Okay, so we are retrieving employees, we are retrieving employees which not belongs to the supervisor, that's what we want. Okay, so retrieve employees which are not equal to any of the supervisor. Okay, so but the problem is not equal to all, not equal to all, this condition is also applied for this null. Okay, so this means this where condition of the first query, where condition of the first query is become like this. Okay, so EID not equal to all, not equal to all is okay, end comparison and end connectivity. Okay, for all the values of the sub query. Okay, that means it is logically equal to EID not equal to null, because null is also one of the value over the attribute supervisor ID. Okay, so and so EID not equal to E1, EID not equal to E1 and EID not equal to E2. So this is the logical meaning, this is the logical meaning of EID which is not equal to the subquery result. Okay, so comparison with null is unknown. Okay, comparison with null is unknown. Because comparison with null is unknown, okay, if these two conditions are false and unknown, result is become unknown. If one of this condition, if these two conditions are true, true and unknown, okay, the result is unknown, sorry, false and unknown is result is false, okay. That means the overall result of this expression, either unknown or false, overall result of this expression either unknown or false, never be true, okay, either it can be unknown or it can be false. So because of that, the result of this first query, empty record set, 0 tuples, 0 tuples in result. In case no supervisor attribute value, okay, so this kind of null values are not there. If this kind of null value, every AID, every employee having some supervisor, for example, then both are correct, okay. So in case if there is some supervisor ID value is null, then first query is empty set, okay, because so the all is end connectivity with, okay, so for not equal comparison with end connectivity. So one of the thing is comparing with null, which is unknown and true, unknown and false, whatever the case, the result is either unknown or false. So no record of the employee table come into the result, okay. Now to avoid this problem, we have to eliminate null in the subquery result. So that is what we done here in the second part. So here the inner query result eliminated, only E1 E2 is the inner query result. Here inner query result is null is there and E1 is there and E2 is there, but here inner query result is E1 and E2. So this all is behaves like this, okay. So EID not equal to E1 and EID not equal to E2, okay. So now comparison with null is not there. If it is true, then he is not supervisor. If it is false, then he is a supervisor. Then based on that, he will get correct result. The second query gives the correct result. First query wrong for the given specification. So which is correct query for the given specification. It means only Q2 is correct. Right? Clear this one? Right. So next question. It is much simpler question. Okay. So two instances are given. How many tuples in the result of given SQL query? Select star from relation R where B greater than any. B greater than any. Okay. Is the one first question. So C values of S relation, and select star from R relation where B greater than all. Select C from S relation. So number of records in the result of this query. Okay. Everyone try it. So let me embed it, okay. So that is easy for giving the answers in chart. Assume this is 11th first part and 11th second part. right, very good. Nilitpal, Nath, Vonika, Hari Krishna, Hita, Divyansh, Ishwar, Akshay, Asuna. Right, majority are given correct answer. Okay, so the same as the previous question, see any function behaves like R connectivity. Okay, because it should be equal to at least 1, sorry, greater than whatever the comparison. Okay, greater than at least 1 means, okay, R connectivity okay with given comparison greater than for all C values, for okay inner Curie values, inner Curie result. So the C values of oscillation having null, okay, that means this any becomes like this. Okay, this B greater than any behaves like this. Okay, so B value is one of the record attribute value, B value is greater than 5, R, B value is greater than 4, R, B value is greater than null, R connectivity with the given comparison, greater than null, R, B value is greater than 8. This is the comparison tested by the where clause. This where clause do this comparison. Even comparison with null is unknown. Okay, even comparison with null is unknown. It will not create any problem. Because of R connectivity. Okay, if one of other comparison is true, the overall result is true. If no other comparison is true, means assume that B greater than 5 false and B greater than 4 false, B greater than 8 false are unknown, and the result is unknown. Okay, so but it's not going to be violate the requirement of the given specification. Okay, so if you take B is 15 greater than 5, 15 greater than 4 and 15 greater than 8, true, and this record is in the result. 10 greater than 5 and 4 and 8 is also true. If I take 4, okay, 4 greater than 5 false, 4 greater than 4 false, 4 greater than 8 false is not in the result, 10 is not in the result. Okay, 2 records in the first relation. Okay, so the all function and connectivity with all values of inner Curie result. Okay, this all, that's what we discussed in the previous question. So and connectivity for all values of the inner Curie result. Okay, so B greater than 5 and B greater than 4 and B greater than null and B greater than 8. Okay, and because of comparing with null value is unknown and false. Okay, the result is become false, unknown and true, result is become unknown. Okay, the result never be true, this expression result never true. Okay, so that means this result is never be true, where condition false for all the records, it retrieves 0 records. Okay, it retrieves the 0 records, right? So if null is there in the result of inner Curie, no problem for any function or in function. Okay, if null is there in the result of inner query, okay, all function overall become false and not in function is also overall become false. Okay, so this is one good conceptual thing related to the null comparison with any function and null comparison with all function, right? So clear this? Right. Now, so how many number of B trees possible for the 9 keys? 9 keys is given. How many number of B trees are possible? Where order P is 5. Where order P is 5, it is between, okay, between 2 to P block pointers. Okay, so between 2 to P block pointers for the root node and between P by 2 seal value to P block pointers for other nodes. Okay, it means so between 1 to 4 keys, minimum 1 maximum 4, minimum 1 maximum 4 keys for the root node, and so other nodes P by 2 seal is 3, so minimum 2 and maximum 4, minimum 2 and maximum 4 keys for remaining nodes. Okay, the question is, if you have 9 keys, 9 distinct keys, if you have 9 distinct keys, okay, how many different possible B trees? How many different possible B trees, right? Think it and try it. It's not difficult question, easy question only. Shruti, Vaibhav, Aman, Raman Singh, Divyanshu. Sejal, check it again. Akshay, check it again. Bhunesh, check it again. Sumit. Okay. Okay. So this is see, this kind of numerical questions are very frequent from the B tree and B plus tree. From B tree and B plus tree, numerical questions are possible. Okay. So number of possible B trees. Okay, see, if you take one key in the root, one key is allowed for the root. If you take one key in the root, okay, so this node can be maximum 4 keys. Okay, this node can be maximum 4 keys. Okay, is okay, 9 keys is okay, 4 keys and 1 key and 4 keys is one possible tree. It means if I take 5 is root, if I take 5 is root, it is one possible tree. Okay, so this is the one possibility of tree. 5 is root and this left subtree is maximum 4 keys, 1 2 3 4, and right subtree maximum 4 keys, okay, 6 7 8 9. It is one possibility of tree. Now, is there any possibility where we can take 2 keys in the root? Okay, if I take 2 keys in the root, I need 3 child pointers because B tree all the leaf nodes should be at the same level. Okay, so 2 keys means 3 leaf nodes should be there. Okay, so the number of block pointers should be one more than the number of keys. So to have 2 keys in the root level, okay, so at least 2 keys required here, minimum 2 keys required here, at least 2 keys required here, at least 2 keys required here, 2 2 2 and 2, minimum 8 keys required, minimum 8 keys required to take, minimum 8 keys required to take 2 keys in the root, but we have 9 keys, it is also possible. Okay, I can take 2 keys in the root also. Okay, so what are the possibility? I can't take 2 is the root because left side only 1 key not allowed. Okay, so now if I take 3, then 2 keys in the first node because minimum 2 keys required, other than the root minimum 2 keys is mandatory. Okay, so 3 is the root. So then, so the remaining how many keys are there? 1 2 3 4 5 6 keys are there. Okay, among the 6 keys one more key should go to the root because 2 keys we are considering from the root. Okay, I can't take 5 is the root because if I take 5 is root, then here only 4 is possible, 1 key is not allowed, so we can't possible to take the 5. But so we can take okay, so 6 we can take, okay, 6 we can take as the 1 key. So 6, then 4 5 is here and 7 8 9 here. Okay, not only one possibility, so instead of 6 we can take 7 is the root, so you can take 3 7 is the root, 2 keys 1 2 and 4 5 6 and 8 9 is also okay. Other possibility, the first leaf node you can take the 3 keys, that means if 1 2 3 is the first leaf node, then I can take 4. If 4 is the root, if 4 is in the root, other key, so 2 keys in one node and 2 keys in one node, other possibility is only 7. So like this, okay, so 5 6 and 7 8. So these are the 3 possible trees where root have 2 keys, 3 possible trees. Okay, and one tree with root is 1 key. Okay, total we got 4 trees so far. Okay, so is there any possibility I can take 3 keys in the root? Okay, if I take 3 keys in the root, I need 4 leaf nodes, 2 keys and plus 3 keys, 8 plus 3. So minimum I need 11 keys. Okay, minimum 11 keys I need, but we have only 9 keys. Okay, there is no chance to go for the 3 keys. Okay, 3 keys in the root. Okay, root can be 1 key and root can be 2 keys for the given set of keys. Okay, if you have at least 11 keys, then it is also one possibility, right? So then no other possibilities exist. So the answer to this case, total 4 B trees. So this is 1 and these are 3, right? So like this you need to see the all possibilities, you need to see all possibilities. So whereas a binary search tree, total number of binary search trees, okay, we have a well defined formula 1 by n plus 1 2 n cn, so which we studied in algorithm GTQ session yesterday. So but there is no such simplified, because it depends on the order also, okay, it depends on the order also, we can't generalize B tree. So because a lot of possibilities, lot of different possibilities depends on the order and all, okay. So we need to recheck them manually, okay. So is one possibility, they may give less number of keys also, okay, 4 5 6 keys, and they may ask how many possible trees and all, okay. So hope it is clear. This same question is going to be study B plus tree, okay. So now try this one, same thing. So total 9 keys are there, B plus tree, how many possible B plus trees are there? So the order is given root 1 to p minus 1, it means minimum 1 maximum p minus 1 means 4, okay, minimum 1 maximum 4 keys for the root node, minimum 1 maximum 4 keys for the root node, and other nodes p by 2 seal value is 3 minus 1, so minimum 2 and maximum 4 keys for other nodes, okay. Then total 9 keys are given, how many possible B plus tree? So it is little maybe little time consuming, so let take 2 minutes time, try it. So otherwise I will explain this question. I considered little different model questions, okay, so which are possible because the same easy question and all you already know that, okay. So no worry, even if by chance your answer is wrong, don't worry, just try to understand. So all the keys must be at the leaf level, all the keys must be at the leaf level. You should also consider left biasing as well as right biasing. All the keys must be at the leaf level, you should also consider left biasing as well as right biasing. take time, no hurry, no hurry, take time, do calculation properly. Right. Okay, so I will give some hint, I will give some hint. Okay, see, it's a B plus tree, it's a B plus tree, you know all the node, all the keys should be at the leaf level, all the keys should be at the leaf level. Focus leaf design, focus different, how many different possible ways, okay, how many different ways you can make the leaves, okay, so how many different ways you can design the leaf, okay, so like one leaf node can be at least 2 keys, one leaf node can be at least 2 keys, and one leaf node can be at most, okay, 4 keys, at least 2 keys, at most 4 keys, maximum possible different ways you can distribute the leaf, okay. So for first of all, see, the total 9 keys are given, 9 keys are given. If I take only one key at the root level, if I take only one key at the root level, so all the keys should be at the leaf level. So here I can take maximum 4 keys, okay, maximum 4 keys. Here I can take maximum 4 keys, okay, and all keys should be at the leaf level. So the if I take one key at the root level, maximum okay, 8 keys only I can store in the tree, maximum 8 keys only I can store in the tree, okay, like assume 1 2 3 4 and 5 6 7 8, okay, then only one key, okay, so either 4 or 5 based on the left biasing and right biasing, but the keys are 9, keys are 9, so it is not possible to take the one key at the root, okay, because number of keys are more than the requirement of one key of the root. If one key at the root, the two leaf nodes, this leaf node can be at most 4 keys, this leaf node can be at most 4 keys, 4 keys plus 4 keys, maximum you can able to store 8 keys, okay, but the given question 9 keys are there, so that means this case is ruled out, okay, this case is ruled out, one key in the root. So other possibility, I can take 2 keys in the root, okay, if I take 2 keys in the root, what is minimum requirement, minimum and maximum requirement? So if 2 keys in the root, so 2 plus 2 plus 2, minimum I need minimum 6 keys, minimum 6 keys required, our number of keys are more than 6, maximum, so 4 plus 4 plus 4, maximum 12 keys is possible, because our required keys are more than minimum requirement and less than maximum requirement, okay. So this is not possible for 9 keys, and this is possibility, okay. Now so the one thing, that if I take 2 keys of the root level, 2 keys in root, then how many ways you can distribute, okay. So these are the keys, like 1 2 3 4 5 6 7 8 9, okay. So 2 keys one node and 2 keys one node if I take, okay, but see 3 leaf nodes, na, 2 keys means 3 leaf nodes, it is not possible, okay, because so 5 keys in the third node is not possible, means at least at 2 we can't possible to take. Assume that the first node 3 keys you considered, first node 3 keys you considered, then remaining how many these keys, 6 keys, okay, if you take 2 keys, then okay, so if I take 2 keys here, 1 2 3 4, a possibility is there. If I take 2 keys here, so now the remaining 7 keys are there, 7 keys are there. So I can take, okay, so 4 keys in one node, 4 keys in one node, 2 keys in other node. Okay, other possibility, okay, other possibility. So 3 4 5 6 7, okay, 8 9, okay, 3 keys in one leaf node, okay, and 4 keys in other leaf node. Yeah, it is only maximum 5 is maximum 4 is allowed. 4 keys in this leaf node and 3 keys here. 4 3. Okay, so 4 3 we can consider. Otherwise 3 4. Okay, so means these are the 2 trees. These are the leaf nodes. So first leaf node, second leaf node, third leaf node. First leaf node 2 keys, second leaf node, okay, 3 4 5 6 7. 4 keys, and third leaf node 3 4 5 6, okay, 4 keys, and fourth leaf node 7 8 9. And left biasing and right biasing. Left biasing means, okay, 2 6 in the root node, and right biasing means 3 7 in the root node. Okay, so this will leads to 2 trees. This also leads to 2 trees, one left biasing and one right biasing. Okay, so these 7 keys are there, 7 keys are there. I can't take 2 5, okay, so 4 3 and 3 4, 2 possibilities. Okay, if I take 2 keys in the root. Other possibility, if first node if I take 3 keys, okay, if I take 3 keys in the first node, okay, so then remaining how many keys are left? So that is 4 5 6 7 8 9, 4 5 6 7 8 9, total 6 keys are there. 6 keys are there means, okay, 2 4 is also okay, okay, 3 is also okay, and 4 2 is also okay. 3 trees, okay, so 3 trees, and every tree 2 2, left biasing and right biasing, 2 ways of 3 trees. What is first tree? Okay, 3 leaf nodes, 1 2 3 4 5 6 7 8 9. Okay, second tree 1 2 3 4 5 6 7 8 9. Third tree 1 2 3 4 5 6 7 and 8 9. Okay, so that 2 cases goes to the leaf node. So the other possibility, so 1 2 3 4 keys in the first leaf node. If 4 keys in the first leaf node, 5 6 7 8 9, okay, 5 6 7 8 9. So I can take 2 keys and 3 keys, or 3 keys and 2 keys. Okay, these are the 2 trees, 1 2 3, like a 1 2 3 4 first leaf node, 5 6 second leaf node, 7 8 9 third leaf node, or 1 2 3 4 5 6 7 second leaf node, third leaf node is 2 keys. Okay, these are the 2 trees, 2 ways, and every way left biasing and right biasing 2 possibilities. Every way left biasing and right biasing 2 possibilities. So like I think, so 1 2 and 1 2 3 1 2 3 4 all are covered. Okay, so 2 keys. Now is there any possibility to take the 3 keys? Okay, if I take 3 keys in the root node, if I take 3 keys in the root node, minimum I need 4 leaf nodes. So minimum I need the 8 keys. Okay, minimum 8 keys. So the given thing is 9 keys, so it is also possible. Okay, so this is 2 keys in the root. The other possibility, I can take 3 keys in the root. Okay, 3 keys in root. If 3 keys in root, I have to take the 4 leaf nodes. If 3 keys in the root, I have to take the 4 leaf nodes. Okay, so the number of leaf nodes should be 4. Like assume 1 2 3 4 5 6 7 8 9. If I take 1 2, is the first leaf node. I need 3 other leaf nodes. Okay, because total 4 leaf nodes I need. Okay, so the 3 keys in the root means 4 leaf nodes. Okay, I have to distribute into like assume 2 2 3. Otherwise, okay, 2 3 2. Otherwise 3 2 2. okay, because total remaining 7 keys has to distribute into 3 nodes. Okay, 2 keys 3 3 keys, or 2 keys 3 keys 2 keys, or 3 keys 2 keys 2 keys. Okay, okay, 1 2 3 3 trees, and every tree left biasing and right biasing. Okay, 3 trees, every tree left biasing and right biasing, 2 ways. Okay, so then other possibility, first node if I take 1 2 3, first node if I take 1 2 3, the remaining keys 4 5 6 7 8 9, remaining keys 4 5 6 7 8 9, this has to be distributed into 3 nodes, because total I need 4 leaf nodes, first leaf node, remaining 3 leaf nodes. Okay, so only one possibility, because at least 2 keys are required. Okay, so only one possibility, and which is left biasing and right biasing, 2 trees. Okay, now if I can't take 4 keys, okay, if I take 4 keys in the first leaf node, if I take 4 keys in the first leaf node, only 5 keys in the remaining 3 leaf nodes is not sufficient, minimum 6 keys are required. So I can't, these are the possibilities for 3 keys. Okay, so then how much is this? 6 plus 2 8. Okay, so 10 12. Okay, so 12 plus 6 18, 18 plus 4 22. Okay, so these are the total possibilities, total number of B plus trees, total number of B plus trees are 22. Okay, so practice it again. So in case if you are change the data, instead of 8 keys you can take 9 keys, or okay, 10 keys, or 7 keys. Okay, so reduce the input size and try it. Okay, this is one most possibility is there. This model question from B tree B plus tree not given before, so almost every model of the B tree B plus tree is almost given. Okay, this is this kind of model of total number of B trees they use it to ask in the data structure point of view. Sorry, total number of binary search trees. Similarly, total number of B trees and total number of B plus trees. So possibility is there. Okay. So who is that? Ankur. What if we consider 3 levels, 2 levels? Very good question. If I consider 3 levels, so anyhow I need to take minimum possibilities that is satisfied or not. If I take 3 levels, so 1 key minimum here, 2 keys minimum here means 3 pointers, and 2 keys minimum here 3 pointers. Then so 1 2 3 4 5 6 leaf nodes. Okay, 6 leaf nodes, 6 multiplied with minimum 2 keys, I need minimum 12 keys. Okay, minimum 12 keys, then only I can go for third level. Okay, so according to, because at least each leaf node should be 2 keys. So if I want to go 3 levels, minimum I need 12 keys. If minimum 12 keys are there, then third level also has to be considered. Okay, so but here only 9 keys are given. 9 keys is not sufficient to grow the third level, right? Clear this one? Yeah, I have to check every possibility, obviously. Total number of trees, na? Right? Shall we move to the next question? So this is a simple question only, you can easily able to do. Okay, so I think we can move to the next question. See, total 100 leaf nodes are given. Okay, number of leaf nodes are 100. It's not 100 is not the number of keys, number of leaf nodes. Okay, 100 leaf nodes are exist. And you need to compute the minimum possible internal nodes. Minimum internal nodes. Very good. Very good, very good. Okay, so majority given correct answer. Try it again, those who are missed. Okay. So to get the minimum internal nodes, we have to consider, so maximum node filling factor. Okay, maximum node fill factor, because minimum nodes we need. So maximum node fill factor. So internal node maximum 5 pointers and 4 keys. Maximum 5 block pointers and 4 keys. So maximum 5 block pointer, 4 keys per node, right? Now total 100 leaf nodes. 100 leaf nodes means the previous level we need 100 block pointers. Okay, bottom up approach we can consider 100 block pointers. So 100 block pointers are there. Every node can capable to store at most 5 block pointers. Internal nodes we are designing based on the block pointers. Okay, so if it is not exact divisible, because we are considering maximum filling factor for node, you have to consider the seal value if in case if it is not exact divisible. But anyhow 100 by 5 is exact divisible. 20 nodes. Okay, so 20 nodes at this level. So the previous level we need, okay, if this is 100 block pointers can be distributed into minimum 20 nodes. 100 block pointers distributed into minimum 20 nodes, right? So now, so minimum 20 nodes are exist in this in level. If this 20 nodes are there here, it means 20 block pointers required in the previous level. Okay, so 20 block pointers, one node can be at most 5 block pointers. In case not exact divisible, you can take the seal value. Okay, so it is 4 nodes. Okay, and this previous level we need 4 block pointers. 4 block pointers, anyhow 1 node is sufficient. Node can capable maximum 5 block pointers. 4 block pointers, 1 node means it is a root node. Okay, so total 20 plus 4 plus 1. Okay, so 25 is the minimum internal nodes. Minimum internal nodes is 25, right? This is the one frequent model question. So the bulk loading question also once in the previous gate is given, but remaining model questions of B3, B plus T repeatedly given. So these models are possibilities there. Okay, so these days they are increasing standard of the paper, so possibility is there. So just practice it, these kind of questions also, right? Yeah, bulk loading concept. So whenever leaf nodes are given to construct internal nodes, or keys are given to find number of nodes. If keys given or leaf given, okay, for the B plus tree you can consider bulk loading. Bulk loading is the better method for this, right? Right. Transaction management question. Transaction management question. Okay. So please think and answer. It is regarding, okay, regarding conflict equality. Okay, regarding conflict equality condition. So which of the following statements is are correct, and multiple selection question. So MSQ. Okay, assume S1 and S2 with the same set of transactions. Transactions of S1, S2 schedules are same. If S1, S2 schedule same precedence graph of the schedule is same, then conflict equal schedules. Okay, so second statement, conflict equal schedules, then precedence graph is equal. And third statement, same precedence graph and acyclic precedence graph, then conflict equal. And fourth statement, same precedence graph and cyclic precedence graph, okay, then guaranteed conflict equal. Okay, so which is true statements for this? Right. Okay, so see this one. So it is conflict equality testing is important for the exam. For example, if two schedules conflict equal, okay, two schedules conflict equal, all conflict pairs precedences are same. Every conflict pair precedence is same means every edge is same. In such cases the schedules are same precedence graph is same. Okay, the reason is, okay, conflict equal, the number of transactions are same, as well as every conflict pair precedence is same, every transaction is also same. So all conflict pair precedences are same means every edge of the S1 schedule precedence graph, every edge of the S2 schedule precedence graph is same. Okay, so now if schedules not same precedence graph, for example some edge in the precedence graph is not equal, then some edge is not equal means the precedence graph is different means not conflict equal. Okay, so same precedence graph need not be conflict equal. Okay, so because same precedence graph, if this forms the cycle, because of this cycle so many conflict pairs can be in the different precedence, but it may be in the same cycle. Okay, same precedence graph need not be conflict equal. Okay, so same precedence graph may or may not be conflict equal, and precedence graph is same and precedence graph is acyclic, then conflict equal. Okay, so these are the four important conclusions which are related to conflict equality versus precedence graph. Four important statements which are related to conflict equality and precedence graph. Okay, just work it out. Okay, so with proper examples and all. So conflict equality testing is very important. Last 3-4 years, last 2 years, okay, so repeatedly giving conflict serialization schedule, either conflict equal schedule question or conflict serialization question. Okay, simple question only. So the DBMS, one best thing in the DBMS for GATE point of view. Okay, so usually 8 marks or 7 marks or 9 marks, 7 to 9 are approximately they use it to ask from the DBMS. Okay, so if you properly study DBMS, then almost you will able to answer every question related to DBMS. Okay, so because more twists and more kind of complications generally not in the DBMS subject in GATE examination. Okay, so definitely they will give very standard model questions. So it is one of the best subject for the scoring. Okay, so if you study DBMS, it is almost like that 7 marks or 8 marks in your pocket. You can consider like you already have those 7 marks. Okay, so such a easy way to score the marks from the DBMS in examination. So got it. So don't neglect and just revise all the topics of DBMS. Don't ignore any topic. Okay, it is queries you can focus little more. That's today also I explained more number of queries compared to the other topics. Okay, generally queries you have to practice little more, because 2 mark questions used to ask from the queries. Okay, so other topics also, so ER model also important, transactions also important, BB plus tree and indexing is also important. Okay, so every other topic is also important. Okay, so got it. So this is about the question. The same precedence graph, because of same precedence graph can have a cycle also. Okay, so need not be conflict equal. Okay, so conflict equal, definitely precedence graphs are same. Then same precedence graph and acyclic precedence graph, then conflict equal. And same precedence graph and cycle is there, need not be conflict equal. Okay, so 4 important conclusions, and it's not like remember these statements blindly and work it out. Okay, just work it out, and so try to understand proper reason for that. Okay, just do some analysis, don't try to blindly remember the statements, it's not required. Okay, so once you analyze and leave it, and automatically you will get that logic while you are solving the problem. Next question. Is related to 2PL and conflict serialization. Okay, which of the following statement is are true? Which of the following statement is are true? If schedule allowed by 2PL, then is conflict serializable. If schedule is conflict serializable, then also in 2PL. Not conflict serializable, okay, so then not allowed by 2PL, and not conflict serializable may allowed by 2PL. Okay, so which of the following statements is are true? It is also multiple selection. Scoring 40-45 marks in OTS. So in see the MEDIZ OTS, so it is not like a exaggeration. Whatever the number of marks you are scoring in the MEDIZ OTS, okay, approximately closely similar marks you will also score in the final exam. Okay, so almost, because you can say you may score little more marks only, but not less, because in GATE exam is also surprisingly you will see some new questions in final exam also. it's not like all are repeated or something like that. So be ready to face some new questions, and that is usually in the GATE examination. But similar way we formed in the MEDISE test series, okay, and sample size is also more, and what that based on means number of students who appear MEDISE test series is also more. Because of more sample size, then your rank estimation is also almost similar, okay. But don't get tension if you get less marks in one test, okay. So FST full syllabus test, 8 full syllabus test plus 4 marks, okay. So even if you start daily one test from now, maximum 7-8 tests you can able to finish, okay. So one test maybe you get little less marks, one test maybe little more marks, so but give more number of full syllabus tests. Right. So see, if you take the expressive power diagram, so like serial schedules always satisfy any protocol condition, okay. Serial schedules is also 2PL schedules allowed in the 2PL. Serial schedule also conflict serializable, okay. So serial schedule not going to be create any violation for any of the protocol. Serial schedule by default allowed by anyone, okay, every protocol. So then if you think about conflict serializability as well as 2PL, okay, 2PL schedules, okay, 2-page locking 2PL schedules and conflict serializable schedules like this expressive power. It means that every schedule which allowed by the 2PL, guaranteed conflict serializable. If schedule is 2PL, schedule is satisfied by the 2PL, that schedule guaranteed conflict serializable, okay. And not every conflict serializable can be allowed by the 2PL, okay. Some conflict serializable may fail to execute by the 2PL, some conflict serializable can possible to execute by the 2PL. So here important statement, one conclusion, okay, if schedule allowed by 2PL, guaranteed conflict serializable, okay. If schedule is conflict serializable, may or may not be 2PL, okay. Every 2PL schedules are conflict serializable, but not every conflict serializable schedules can be allowed by the 2PL, okay. Just look the statement, okay. So if schedule allowed by the 2PL protocol, then it is conflict serializable schedule, true. If schedule is conflict serializable, then also allowed by 2PL, okay. If it is conflict serializable also allowed by 2PL, may not be allowed by 2PL, okay. If schedule not conflict serializable, not allowed by 2PL is also true, okay, because 2PL expressive power subset of the conflict serializability. If schedule is not even out of the conflict serialization, that schedule out of 2PL also, okay. So it is also true statement. And if schedule not conflict serializable may allowed by the 2PL is false statement. So answer to this question is A and C, right. So that means, so from transaction management, so see from the conflict serialization, view serialization, there may be a numerical question or testing of conflict serialization, testing of view serialization, that kind of questions, okay. From protocols, from locking protocol or timestamp ordering protocol, mostly this kind of conceptual question, okay. almost every time in the previous gate whenever they ask question from protocols, okay, so that it should be a conceptual, okay. I mean, and these days because of multiple selection, this kind of conceptual question possibility is increases, right. So you focus locking protocols and timestamp ordering protocols conceptually, and solve more and more numericals as well as conceptual things related to conflict serialization and view serialization from transaction management, right. So okay, try this one. Two transactions are given, read A, R1A, R1B, first transaction, read A, read B, and W1A, W1B, read A, read B, write A, write B, sorry, okay. If lock request of transaction by using 2PL protocol as per the order of data items that are used by transaction, okay, it means see, A is using first, A should be locked first, B is using, B should be locked, okay. So lock ordering as per the requirement of the transaction, okay. Transaction A should lock A and then lock B, and transaction T2 also should lock A and lock B is the given assumption or constraint, whatever we call. So what is our statement? Concurrent execution of T1 and T2, okay, may forms deadlock, okay. So 2PL protocol, using 2PL protocol, concurrent execution not forms deadlock, okay. Some at least one non-serial, okay, other than the serial, at least one non-serial is, okay, serializable schedule between T1 and T2, at least one non-serial schedule, okay, is, okay, every, not at least one, every non-serial schedule is conflict serializable, okay. At least one non-serial conflict serializable, every non-serial conflict serializable, two options related to serializability and two options related to deadlock. So for this T1, for A and B, deadlock questions are for the 2PL based, right. Try it. Seeing total number of conflict schedules, so just post in the telegram group of MedEasy, okay, will explain that. Rohit, I have not given basic level test, so try it, still time is there, okay. Daily one test you try to give from now to at least till 31st January, okay, 4-5 days, daily one full syllabus test, okay. So revise and full syllabus test, if in case one or two small areas you are failed to recollect or you are not confident, just try to ignore, okay. Last moment don't try to study the new things, okay. So just revise the things which you are confident, and keep revise and keep give the full syllabus test, right. It is also MSQ, multiple selection, it is also MSQ question. Which of the following, what are correct statements? MSQ question only. How many of you first time GATE? By, okay, Which question you make in test need very concentration? Didn't understand, Ankur. 50 to 60 in basic level test. Basic level test also a good kind of question, because I seen the question standard while giving recorded lecture. Okay, solution for the recorded lecture. So test series questions are really good, and so try to do maximum number of test series. Now focus full syllabus tests instead of subject level. Algorithm DBMS questions in OTS solved very carefully, good. Sixty plus marks in test series is good enough. Okay, 55. Right. Okay, so see this one, the T1 transaction and T2 transaction, these are the two transactions given. Okay, so the transaction should log the data as per the sequence of the sequence of execution. T1 should log the A and log the B. After all the logs, then only it is allowed for unlock, order of A and order of B. Okay, so this T2 also should log A exclusive mode and log the B in exclusive mode because of write operation. So then only it is allowed for unlock the A and unlock the B. And in between, of course, write A, write B should be performed. Okay, so this is the sequence. So see how you will test for deadlock. Okay, so in the transaction management point of view. Okay, so in transaction management point of view, 2PL point of view, I am trying to explain deadlock possibility, how you can test it. Okay, for example, if T1 begins, and it will log the A, it will log the A in shared mode. Okay, so T2 can't get the first lock, T2 can't get the first lock until T1 come to here. Okay, until T1 come to unlock of A, T2 can't possible to continue. It means that T2 should wait until T1 is unlocks the A. T1 is started unlocking the A, means T1 not required data related to T2, means a lock which is held by T2. Okay, then only T2 is required to wait for T1. In that case, it is not a deadlock, na? So only one transaction wait for the other transaction in case T1 begins first. If T1 took the T1 holds the shared lock of A in case. Okay, so exclusive A of T2 is granted only if T1 start unlock the A. Okay, when T1 is unlocks the A, after shared lock A, read A, shared lock B, read B, unlock A, after it reaches to here, then only T2 can continue. That means T2 can wait for T1, but T1 not required to wait for T2. You can think in other reverse order. In case if T2 begins first, it locks the A in exclusive mode. if T2 locks the A in exclusive mode, okay, until T2 unlocks the A, T1 can't continue. Means not even get their first lock. That means here T1 required to wait for T2, T2 not required to wait for T1. Okay, so if the lock data items which are used by the 2PL protocol is locks in the same sequence, data item which are used by the 2PL protocol locks in the same sequence, A first then B and A first and then B, no chance to form the deadlock. Okay, no chance of deadlock using 2PL if, okay, transaction locks the data item in same sequence order. Transaction locks data items based on sequence of data item addresses, means same order. Okay, so okay, whatever T1 trying to log the data in the same order or one sequence order, now need not be a same order. For example, if the data items are like this, assume that data item is A, B, C, D, E, F, okay, like this is there. Every transaction should log the data in the same sequence. If every transaction should log the data in same sequence, so in that case 2PL not forms any deadlock. Okay, so the may forms deadlock is false statement, it is free from deadlock. Okay, so some non-serial concurrent execution of T1 and T2 serializable schedule. Okay, yeah, yes, some are serializable, not everyone is serializable. Okay, so you can take two schedules. Okay, you can take two schedules which are non-serial. Okay, so T1 and T2, T1 reads A, then T2 is writes A and T2 is writes B and T1 is reads B. This is one non-serial, and take one more non-serial schedule. Okay, T1 and T2, not a serial schedule. Okay, T1 reads A and T2 is writes A and T1 reads B and T2 is writes B. Out of these two, this is the one of the non-serial which is not conflict serializable schedule, because cycle in the precedence graph, it is conflict serializable schedule. Okay, now read the third and fourth option. Some, at least one non-serial schedule is conflict serializable. True, at least one non-serial, like the example is this. Okay, at least one non-serial is conflict serializable. Every non-serial conflict serializable is false, because some are not a conflict serializable schedule, some non-serials are failed for conflict serializability, so it is false. So B and C are the correct statements. Okay, so like always transaction management question, good logical, good conceptual question. So it's a means in GATE examination point of view. Okay, it's one important pattern. Okay, this question, similar pattern. Okay, same logic, same point which we explained for this question 3 times repeated in the GATE examination in different formats of the question, but logic of the statement is same. Okay, so same thing. Okay, same about the deadlock and same about the non-serial conflict serializability, non-serial not conflict serializability. So 3 to 4 questions are there in the previous GATE with the same concept, right? So last question before closing the session. Okay, so last question of today's session. Okay, so see this one. T1 similar to the previous pattern. T1 read A, read B and T2 write B and write A. Okay, if lock requests of transactions by 2PL, okay, as per the order of data items, it's not like as per the order of data item addresses, it is like as per the order it is used by transaction. It means A is locks then B and T2, B locks then A. Okay, not as per the order of data item sequence, as per the order of transaction using sequence. So T1 read A and read B and T2 write B and write A. then which of the following statement is are correct. Okay, it is also multiple selection question. Okay, so let me see how many answers this question correctly. Right? Very good, Kundan Kumar. Okay. See here, data items which are used by the transactions in different order, data items which are used by the transaction not same order. So transactions are using the data items in different orders. Okay, right. See, if transaction requests the data as per the order it is using, okay, as per the order it is using, T1 should request shared lock of A and shared lock of B, and it should unlock the B, unlock the A. Unlocking is not matter, okay, so but locking is important here. So unlock A as well as unlock B. Okay, unlock sequence not create much problem, but this lock sequence. Okay. So exclusive lock of B and exclusive lock of A, and because B is writing first and then data item A is written, okay, so unlocks the B as well as unlocks the A. Okay, all locks then unlocks, right. Now if transaction should request the lock as per the data item it is used, order of the data item it is used, A is using and then B, so A should lock then B, and B using and then A, and B should lock then A, right. If this is the case, is it forms the deadlock? Yes, in this case it is possible to form the deadlock. In case if T1 begins locks A and T2 begins locks B, okay, even if T1 locks A, lock B of T2 is possible. Assume T1 begins locks A before locking B and T2 started, and T2 is locks B. Okay, so A is held by the T1 and B is held by the T2, and until T1 get the data item B, it will not release the A. Until T2 get the A, it will not release the B. So T2 not unlocking the B and waiting for the A, and T1 not unlocking the A and waiting for the B, it can form the deadlock. Okay, so that means this is the expected schedule. Okay, this is the expected schedule. So for example, T1 is reads A and T2 is writes B, and T1 requesting for read B and T2 required to perform write A. So if this is the case, so T1 begins shared lock of A and T2 begins exclusive lock of B, both are granted. Okay, now T1 shared lock B request is denied, okay, and T2 exclusive lock A request is also denied. Okay, so until T1 get the shared lock of B, he will not release A. Until T2 get exclusive A, he will not release the B. So that means it may forms the deadlock, and it's not deadlock free. If data items which are used by the transactions in different order, possible to get the deadlocks. Okay, so some non-serial schedule, okay, is conflict serializable schedule. See here, the last operation of T1 and first operation of T2 is conflict, read B and write B, and last operation of T2 and first operation of T1 is conflict. In that case, none of the non-serial schedule is conflict serializable. Okay, so if you take two transactions, T1 having some set of operations and T2 having some set of operations. Okay, so for example, this last operation of T1, okay, so something like read of X, Okay, let us say a read of some data item A, and this first operation is write of data item A, some conflict, write, read, read anything, and this first operation and this last operation, like assume that this first operation is a read of some data item E, and this last operation is write of some data item E. If first operation of T1, last operation of T2 conflict, these two conflict, and the first operation of T2 and last operation of T1 if conflict, if such a two transactions is considered, except serial, every non-serial schedule is forms the cycle in precedence graph. Every non-serial schedule forms the cycle in precedence graph. For example, two transactions and two operations and two operation, total 64 schedules, 4C2 schedules. 4C2 schedule means 6 schedules, out of 6 2 serial schedules. Okay, if you eliminate those 2 serial or non-serial, remaining 4 non-serial schedules, you can write all 4 non-serial schedule. None of the non-serial schedule is acyclic in the precedence graph. Every non-serial schedule is forms the cycle. Okay, so at least one non-serial conflict serializable is false. Okay, so at least one non-serial conflict serializable is false. So every non-serial is failed the conflict serializability. It is also one important thing. So based on this concept, so 2-3 times in the previous GATE question. Okay, so covered a maximum possible good question. So also please go through the 2022 quick revision, 2022 GATE quick revision, GATE through question GTQ questions 2021. So 3 years. So because already last 2 years are in the YouTube, so I covered questions such a way that which is not similar to the previous 2 years. Okay, so otherwise those who are already seen those session and it is get repeat na. So the 2021 GTQ video of the YouTube, 2022 GTQ and 2023 GTQ. So overall you will get 40-50 questions, maximum number of models from the DBMS, and good models of DBMS get covered. Practice these 3 models and give more number of test series. So I know you all little stress for the exam. Of course sometime okay, stress also is good if it is gives the better result. Okay, so means I can't say don't feel stress and all. Sometime okay, for example even I am teaching last 15 years. So before started this session I feel little tense, like a I am giving first time video, first time lecture. Okay, so that stress sometime is it should be there, then only will give the best content na? If without stress and without tension or without the how you will get the best content. Okay, until unless it is creating problem for your preparation or demotivating or something else, so you should ignore that. So otherwise little stress is common, and so please do your best and all the very best for the GATE exam. So let me read your comment. Anything last 2 minutes? Please like the video. How many are giving in 3rd year? It is doesn't matter for that. (17 and 18). Shruti given answer to the Aditya. Thank you so much. Okay, signing off. Thank you all the very best. Okay, so please be in touch after GATE examination, just through the MEDIZI telegram group. Okay, so it is helpful for your further career counseling and all. Okay, all the very best. Thank you. This is all about today's class. Bye.